pretty rewarding, because obviously you're doing something that matters.
I think we've all got to do our bit. We need to be looking at net zero. We need to be looking at sustainability.
I think there's an opportunity for us to be a bit of a catalyst and a model for others to follow in the region.
We try and do within our designs is look at not today or old technology, but the technology of tomorrow.
So this is a full 50 meg sat, which goes up to 16 stations, starting from where you come through at the gate. This is the biggest sat I've ever worked on at the minute. It's always expanding though, it's solar. I was in school and my mum was always the person to say, you need to get a job, you need to wait on at a pub at like 13, and I thought, I'm never doing that. And then at the end of school, my dad was like, get into a trade, any trade that you fancy, and I was like, I don't mind electrical business. Only one thing that always expands, if you know what I mean. It always progresses in some sort of way. There's always something new about it. It never just stays in one lane, does it? It's good to know that the work you're doing is just something that everyone wants. Everyone wants and everyone demands for the future.
Hi, my name's Luke Osborne and I'm the Energy and Emerging Technologies Advisor. No, I'm not. It's a good start, isn't it? I'm the Energy and Emerging Technology Solutions Advisor for ECA. I think we're all aware we need to decarbonise rapidly because we have a huge problem when it comes to climate change. We've got a massive amount of change that is going to be needed. Obviously, our electricity systems have been in place for decades and they tend to have been based on a centralised approach. So you had large power stations serving the grid and providing the power. And now this is changing to a decentralised energy generation version. We have a very short window, probably around a decade, to get 80% of this work done.
Net zero can't happen without the electrotechnical sector. Absolutely not. There's no chance. But we've got a problem, a looming problem now, a huge skills shortage, an ageing workforce, and we need to be engaging. So industry needs around 11,000 entrants per year to meet the forecast demand. Currently we're recruiting around 7,000 apprentices per year.
We'll go up to one then, yeah?
Yeah, and then you can take van.
Yeah,
I just need to get some gear.
Yeah, you're the movie star.
I walked into Steve's office Monday and went, hey, he's a movie star.
Alright Jake, how's it going?
So bad, you?
Yeah, good.
Good. Yeah, so today we were down at 15, dug a trench with Arvin, got that buried and connected back up as the comms.
Jake's a cracking apprentice, yeah, he's really keen, really confident. Yeah, he's adapted really well to the challenges of the industry that we're in. Bringing the next generation through and helping train them up and getting them used to the skills they'll need to work in the electrical and the renewable industry is really important. You need to keep like the turnover high, really.
Net zero for the electrical industry is fantastic, and we need this new generation of young minds to help us get a grip of this, and it's only this generation that's going to do it.
Well, let me follow you. When I left school, I was kind of heart set on becoming an electrician. It works kind of a bit like a family. When you see everyone in the morning, you talk to one another, give each other tips, learning different things off different people. So we're here at Derwent site Belper, on a site by Wielden Brothers, and we are MA Broughton, and we are the electrical contractors here, doing all the electrical needs. So my week, in a nutshell, basically, Monday mornings I drive up to the Sandy Acre JTL Centre, do theory work or practical, and then the rest of the week I'm either on site, first fix and second fixing, or I'm doing, for example, the solar, or fitting the alarms, as you can see on the houses. So it's always on your toes. There we go. I quite enjoyed the Monday though. It's like a bit of a line on a Monday morning. As a school leaver, I'd say an apprenticeship is the best way to go at the moment because you're earning whilst you're learning. So you're getting the knowledge and you're building that kind of foundation for your career in the future whilst earning money. There's a load of different avenues you can go down, whether it's renewable energy, whether it's domestic, commercial or industrial.
I think there's a common myth again around apprenticeships that it's all site-based, for example bricklayers, electricians, plumbers, joiners, when actually there's quite a diverse amount of roles. So I work in building performance. Hello, I'm Tom Russell. Oh Christ almighty, that's the easiest thing in the world, say my name. Hello, I'm Tom Russell and I'm Assistant Building Performance Engineer for Waits. After school, I was looking for an engineering apprenticeship with something that had a positive impact on the environment. The opportunity came in SES in-house to move into the building performance team, which at the time was quite a niche area, but I think as the industry evolves and develops towards net zero carbon, there'll be more and more building performance engineers. Not only is it important to build the buildings correct with a reduced carbon footprint, but it's also important post-build to monitor them correctly. Are we using them how we intended at the design? Are we wasting energy? Are we using them inefficiently? It's all part of the data analytics to increase energy efficiency and reduce wasted energy. One of my main roles is to build these models in 3D and assign the data in. So this is a project in Manchester and we use these different items in the model to assess different impacts on the building. For example, these purple items are adjacent buildings, so buildings in the local surrounding area, and the green items here is local solar shading, which is actually going to be on the project. So these all have effects on the solar impacts and the solar gains within the building. I think it'll be crucial for the industry to bring design teams together earlier in the design process to ensure that reducing carbon emissions are at the forefront of everyone's mind throughout the whole building's life cycle. Oh, that looks good on it. That looks good on it.
So here we are at Charminster Depot. This is a 165 kilowatt peak solar array that we installed in May, and this is typical for our sort of size of commercial solar installations. So this is the inverter position for the solar array at Charminster Depot. I think there's only me in the entire world that's interested in this box. Since we completed this installation in May 2022, sort of 3 months ago, it's generated over 6 megawatt hours for Charminster Depot. There's very little maintenance that needs to happen to these systems at all. You need an annual check, maybe an annual clean of the modules, and that's about it. There's a massive opportunity at the moment in the drive towards net zero, whether that's solar, batteries or EV. The amount of inquiries that are coming in, it's just, I've never seen anything like it. Essentially, your electrical skills, it doesn't matter whether it's solar PV, batteries, EV or commercial industrial electrical work, it's all sort of interchangeable and the skills are definitely transferable. Originally, we first got into renewables in the biogas industry about 10 years ago. Then from biogas, we moved to solar, and then from solar to EV and battery installations really. So it's been not so much a purposeful progress, you just kind of go where the work is, and at the moment the work's in solar, batteries and EV.
Our members have seen a huge demand of late for requests by clients to install increased amounts of on-site generation, so solar PV, battery storage systems and also energy efficiency measures, particularly in commercial spheres but also on the domestic sector as well. In part this is driven by the public's conscious acceptance of climate change and their need to reduce their own carbon footprint.
So we're just coming into the Harewood estate, driving past our deer park, and coming up to our collection of self-catering holiday cottages, electric vehicle charging, and the estate office here, the hub of everything that goes on. Not good to see them there. That's our biomass plant here, and our chip store in shed number 1, and the solar panels on the roof of that powering the energy centre. Harewood's a 4,000 acre estate between Leeds and Harrogate. It's the family home. Been in my family now for 8 generations. This year celebrates the 250th anniversary of the house being completed. I've always loved the outdoors. I did an environmental management degree, travelled the world working on different conservation and sustainability projects, and I moved back here about 5 years ago, wanting to implement some of the things I'd learned on the estate here. We've implemented lots of different solutions. We've put in electric vehicle charging points. We've got a solar array that powers our energy centre, which is a big biomass plant powered by thinnings from our woodland operations. We've reviewed all our office spaces and switched over to LED lighting. In all our developments, there has to be an economic case to do it, otherwise, why would you, I suppose?
I started my apprenticeship in 1966, so that tells you how long I've been doing this. We didn't have such thing as trip switches or RCDs or RCBOs, it was just wired fuses, that's all there were. And I'd say that's changed, and it changes and changes. Always learning. Yeah, you can't turn and say, I'm not going to learn. You're always learning. You'd be a fool if you didn't.
People say these days that people never have a job for life anymore. They move around a lot, but actually a historic estate is one place where people still maybe look for that as a kind of life goal. So training people up on the team is good for us, it's good for them.
Technology is developing very rapidly in this sector, as you'd expect it to do as things move to a maturity level. It's critical to remember that the technologies we need are available now to get the job done, and things will only get better. But we're seeing new developments and new materials coming through, which is looking to move them to the next level as well. So there's continually improvements going on.
So this is Swansea University Bay campus. This is a new purpose-built campus that was started back in 2013. We're currently here today because we're working with the university on a new and exciting project which is looking into innovative technologies which could revolutionise the way we develop projects going forward and ensure that things are sustainable and low carbon. Morning, Chris.
Morning, Mr. Jenkins, how are you?
Yeah, good. You okay?
Yeah, not too bad today. The solar boys just up on the roof stringing the solar panels. All the solar panels now installed on the roof. And as you can see, carport went in over the weekend with solar panels installed on that now as well. So yeah, good progress at the moment.
Well, EFT stands for Engineering Future Technologies. What we try and do within our designs is look at not today or old technology, but the technology of tomorrow. Swansea University are doing this as an R&D project with the specialist division of the university called Specific. Specific work with industry and academia to pull the two together to try and develop products that are scalable within the real world and help reduce carbon within buildings and ensure buildings are energy efficient.
So the solar carport went in over the weekend. Panels on the roof, about 16.5 kilowatts. They are designed to be swapped out with the Oxford solar PV panel, which is a prototype panel.
Part of the project is the installation of a new solar PV carport, which will facilitate about 15.5 kilowatts of PV. And the PV in question is a new innovative technology from Oxford PV with a new material called perovskite, which is going to be much more efficient than the mainstream panels that are currently in production.
So we're in our UK R&D centre. So the R&D centre is where the actual solar cells are first prototyped and developed. So from concept, so the composition, the materials, to building a small device. We're a spin-out from the University of Oxford, and we're focused on developing materials called perovskite for solar cell applications, and more specifically, we're developing a very high efficiency solar cell that can go into almost any ordinary solar module that you see in the world, and hopefully we can accelerate the adoption of solar, which of course is essential to decarbonize the world and address the climate crisis. Silicon wafer, right? And this is exactly what you see on the rooftops all throughout, any place that has solar applications. 95% of the solar today uses these kinds of square-shaped pieces of silicon. They're about 200 microns thick for the solar cells. And what we do is we put some of this perovskite material on top of that silicon solar cell. And although you may not like the concept of the naming, we call it silicon on steroids. Of course, what it really means is kind of like turbocharged silicon. It takes that same silicon wafer, we add this perovskite material on top of it, and now that solar cell is about 20% more efficient than the silicon solar cell that it started with.
That's just an astonishing rate of increase of power. That's what's exciting the solar industry, because of its potential to make cheaper solar power and therefore answer the problems with climate change and the like. What's cute about it is that you can print these things at room temperature. And so you won't have the high energy budget it costs to make crystalline silicon, which are the main cells you see on roofs. I mean, the nice thing about perovskites is you don't need these big plants to make them. So I'm hoping that they can be adopted worldwide, including in countries where they need off-grid solar power.
Definitely there's a lot of opportunity in net zero technology, all of which can be tied together, not just in isolation, but maximised through the use of smart microgrid controls, which can direct energy where it needs to go in line with its preferential use at certain times of the day.
So the job of the EMA, the microgrid controller, is to coordinate the most efficient way of using the energy and where to use it from. So you've got the battery storage unit, the PV, the vehicle to grid charging, and also your main supply. So it will take tariff information, future weather and everything else that is collecting, and use the energy from the most efficient place at that time. So whether that be from the battery storage unit, the BESS, the roof mounted PV, or indeed the vehicle to grid chargers.
Definitely with the development of new technologies in isolation, such as the battery energy storage and vehicle grid chargers, this is the key tool that can integrate them all together and allow full potential to allow energy savings, sustainability, low carbon for all future buildings. So it's important, I think, for people to start learning more than the basic electrical skills and start diversifying to ensure that we can capture the full scope. Oh, dramatic.
So here we are, welcome to Indra HQ. So this is our main manufacturing facility. This is where we produce the Smart Pro product. With Smart Pro, it's single direction, so you can only charge the car. With vehicle to home, vehicle to grid, it's bi-directional, so we can charge and discharge the car's battery. That can be used for supporting the grid, but also for optimising for the homeowner. We look at electric cars as a battery on wheels, so you've got to look at that as a big opportunity. You're putting all of the manufacturing processes that aren't 100% clean into building a battery that's going to sit 95% of its life idle on someone's driveway or in a work car park or a supermarket car park. Why not use that while it's idle? V2X is going to be the future of the energy system, certainly domestically. We look at the history of that technology. You got Fukushima in Japan, and they started to use it for Nissan Leafs, for doctors visiting people where they didn't have power available because of the disaster. That technology, typically a single car and a single appliance, was how that worked. We've taken that into what we called vehicle to grid, which was basically you tie it to the grid, it's integrated with the grid, a bit like a solar inverter would be. More recently, we've moved that from vehicle to grid towards vehicle to home, and that's where we're optimising for the homeowner. So we start to look at things like solar panels on the customer's home, charging up the battery from those solar panels and then discharging back into the grid or into the home when there's demand there.
So this is the V2G that's going to be installed, and this is our test junction box. So I'll plug the V2G into this. This has got a calibrated meter in it, and I'll run a few scripts on it, get this calibrated and ready for the customer. So using this charger, a customer can both charge their car. By doing that, they plug it in using the charging gun. It'll have one of these attached to it when it's installed. They can then charge their car regularly, or they can schedule it to make sure that it charges at the best time of night when it's cheapest for them, depending on the tariff that they use. They also have the ability to discharge from their car during peak times in order to power their house and make things more affordable for themselves. The V2G is now connected to the car and it's currently discharging. You can see here is the battery state, and these status LEDs are moving away from the battery, indicating the car is being discharged and power is going to the grid rather than coming from the grid. I mean, I've seen it grow from just a handful being manufactured when I first started, and then we produced 1,000 within a year or so. And all of a sudden now it's kind of getting all the attention it needed, really. We're looking at the future. The industry is booming at the moment. We personally have grown from, I think, around 30 people when I first started here to about 100 people now in just 3.5 years. There's a lot of chance for companies to be involved in this and to be having an impact on it.
This is one of the V2G that was prepared for us yesterday. We have a preconceived conception in our heads from science at school that electricity flows one way only. So it flows from positive to negative. Well, it does, but positive and negative can move. You know, so if energy is passing that way down a cable normally, it could still pass the other way and it can still go back out onto the grid, which is something we take advantage of.
That's basically V2X in a nutshell, isn't it?
I'm going to say yes, but there's an awful lot more to it. When I was thinking about leaving the Air Force, I said to myself, well, I want to get involved in renewable energy, some sort of technology that's going to benefit, not just earn me money and earn me a living, but actually make some good.
Hey, mate.
Josh, you got the keys for the car, so we can do a bit of a demo?
Yes, mate. Yeah.
Cheers, man, thank you. Like a normal EV charger, take the connector out. Okay, you're gonna press the button, pull her out, and do you want to plug it in the front?
Yeah, sure.
Just
thing.
Push it in, positive pressure, and it should click when it's in.
Okay, fantastic.
Full lights above, we've got a status light, so they will show you which way power's moving. In this case, because we're set to vehicle to home mode and the car or the house is drawing power, what the charger's trying to do is mitigate draw from the grid and draw in power from the car, so from the battery symbol up into the house. Okay, so imagine the logo is the house, so power's moving up now.
So I'm an electrician by trade, not been one for a while though, as it were, but at the minute I work in supply chain for aerospace components. And I'll be totally honest with you, I've even considered myself going back into the trade. Just with the uptake of electrification. Again, I think it's the future, as it were, personally, so I'm incentivised there. But from a job security point of view, going forward, it's only going to go up and up and up, I think.
We are 2 minutes to midnight. We can't carry on the level of carbon emissions that we have. We need employers to offer more apprenticeship opportunity, to really kind of buy into what's going to happen in the future.
There is a lot of work that needs doing. We do need more people involved to do it. But we've had such a change of mindset in the population and in industry and in government over the past 5 years. We don't have a choice not to do it. That's really not an option. This is the time for change, so people need to pivot now.